Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives involving a modulus function. So here we have this problem in which we are given a function f of x which contains two mod functions, that is mod of 2 minus mod of x minus 3, and here f prime of 2.5 is given as alpha and f prime of 3.5 is given as beta, and we have to find out the value of e raised to alpha times beta. So here what we will do, we'll first redefine this function f of x, and we'll get rid of these two mod functions when we find out the derivative of f at these 2 points. So in order to redefine this function f of x, we'll make use of the definition of mod function. So to solve this problem, let us first quickly revise the definition of mod function. Now see, the definition of mod function goes like this. Mod of p is equal to positive p whenever p is greater than 0, and mod of p is equal to 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0, right? So first our aim is to redefine this function f of x, or in other words we can say that we have to first get rid of these mod functions, right? And we try to express this function f of x as a linear function using this definition of mod function, right? So first we'll take care of this mod function, that is mod of x minus 3. So mod of x minus 3 is defined with the help of this definition. So mod of x minus 3 is positive x minus 3 whenever x minus 3 is greater than 0, right? So for p we can take here x minus 3, right? So positive x minus 3 when x minus 3 is greater than 0, or when x is greater than 3. And here mod of x minus 3 is 0 when x minus 3 is equal to 0. So this implies x is equal to 3. And mod of x minus 3 is negative x minus 3 when we have x minus 3 less than 0. So we have x less than 3. So first of all, we'll find out the value of f prime of 2.5. Now here at this point, that is x is equal to 2.5 is less than 3, right? So here if we look at this definition of mod of x minus 3, then here we have x less than 3 and 2.5 is less than 3. So in this case, the definition of mod of x minus 3 should be given by a negative of x minus 3 for all x less than 3, right? So now we can write f of x is equal to mod, and here we have 2 minus, and mod of x minus 3 should be replaced by negative of x minus 3 because x is less than 3, and here x is 2.5 which is less than 3. So we'll write here a negative of x minus 3, right? So let us solve it. So we have mod, and here we have 2 minus minus plus, so we are left with x minus 3. So this is now x minus 1. So now we have f of x is equal to a mod of x minus 1, right? And we have to find out f prime of 2.5. So x is 2.5, right? Okay, now let us again define mod of x minus 1 with the help of this definition. So here we can write mod of x minus 1 is equal to positive x minus 1 whenever x minus 1 is greater than 0, that is x is greater than 1, and mod of x minus 1 is 0 when x minus 1 is equal to 0, which implies x is equal to 1. And here mod of x minus 1 is negative of x minus 1 whenever x minus 1 is less than 0, and it implies x is less than 1. Right, now see, here we have x is equal to 2.5, and 2.5 is greater than 1. Right, so in this case mod of x minus 1 is defined by this expression, that is mod of x minus 1 is positive x minus 1 when x is greater than 1, and our point of consideration is 2.5, and 2.5 is greater than 1. So now f of x is written as positive x minus 1, right? So now from this discussion we can conclude that the modified form of this function f of x in the neighborhood of x is equal to 2.5 is given by this linear function, that is x minus 1. So we have f of x is equal to x minus 1 in the neighborhood of x is equal to 2.5, and this function f of x is now a linear function, right? So now we can simply differentiate this function. So we have f prime of x is equal to d by dx of f of x, and we have now f of x is equal to x minus 1. So the derivative of x minus 1 is 1 minus 0, and this is equal to 1, right? So f prime of x is equal to 1, and when we take x is equal to 2.5, then f prime of 2.5 is equal to 1, right? And f prime of 2.5 is given as alpha, so the value of alpha is equal to 1. So now let us calculate the value of f prime of 3.5. So now our point of consideration is 3.5, and this point 3.5 is greater than 3, right? So and here f of x is given as mod of 2 minus mod of x minus 3. So when x is equal to 3.5 is greater than 3, then mod of x minus 3 is defined by this part of the definition, that is mod of x minus 3 is equal to positive x minus 3 when x is greater than 3, and here x is 3.5, which is obviously greater than 3. So in this case we take mod of x minus 3 is equal to positive x minus 3. So now this function f of x can be written as mod, and here we have 2 minus, and here we have positive x minus 3, right? So this is mod 2 minus, and here we have minus x, and this is plus, so we have plus 3. So this is 3 plus 2 5, so mod of 5 minus x, right? So now in the neighborhood of x is equal to 3.5, f of x can now be written as mod of 5 minus x. Now let us define mod of 5 minus x with the help of this definition. Now see, mod of 5 minus x is equal to a positive 5 minus x whenever 5 minus x is greater than 0, and this implies that x is less than 5, and mod of 5 minus x is equal to 0 when 5 minus x is equal to 0, and this implies x is equal to 5, and mod of 5 minus x is negative of 5 minus x whenever 5 minus x is less than 0, and it implies x is greater than 5. So now here our point of consideration is 3.5, right? And mod of 5 minus x is defined as positive 5 minus x when x is less than 5, and x is 3.5. and 3.5 is obviously less than 5, right? So now this function f of x can be written as positive 5 minus x when x is less than 5 and x is 3.5 and 3.5 is less than 5. So in the neighborhood of x is equal to 3.5, the modified form of f of x is given by 5 minus x, and this is again a linear function, right? So now we can differentiate f of x. So we have f prime of x is equal to d by dx of f of x, that is d by dx of 5 minus x. Now the derivative of 5 is 0 being a constant, and the derivative of x is 1, so we have minus 1. So f prime of x is now equal to minus 1, and our point is x is equal to 3.5. So here we have f prime of 3.5 is equal to minus 1, and f prime of 3.5 is given as beta. So the value of beta is equal to minus 1. So here we write beta is equal to minus 1. So now we have the values of alpha and beta. Alpha is 1, beta is equal to minus 1. So we can now easily find out the value of e raised to alpha times beta, and e raised to alpha times beta is given by e raised to 1, and here we have minus 1, and this is e raised to minus 1, so this is 1 over e, right? So the value of this expression, that is e raised to alpha beta, is equal to 1 over e.